a little late. So anybody who is watching this video a little late, I'll be posting it on YouTube as well, and sending a link out for those people. But anyway, so we're starting off a little late here, and you can see what we were talking about was basically acids in regards to their acidity from a pH of 1 for acids, and bases being from 7 to 14. Anyway, so we're going to move on. So we were talking a little bit about antacids. So we have milk of magnesia. It's an antacid. It's one that's been around for quite some time. It's the antacid known as magnesium hydroxide. So it has the formula MgOH2. We have, Tums. Right, Tums is another one. Been around forever. You'll see in the lab I'm using the generic version of Tums, and that's calcium carbonate. Then we have Rolaids. And Rolaids is a mixture of both the calcium carbonate plus the magnesium hydroxide. And there's a reason to do that. The reason for that is calcium carbonate reacts very, very quickly, whereas magnesium hydroxide is much slower to react. So you get kind of an instant relief followed by a lasting relief in regards to how it works. Then we have, before commercial substances, you could actually just buy typical baking soda and use baking soda, and that baking soda exists in the form of sodium bicarbonate, right, NaHCO3. And last is Maalox. And Maalox is actually a combination of both aluminum hydroxide and magnesium hydroxide. So you can see the variety of different substances we can use that are bases that can neutralize and react with our acids in our stomach. We have, if you look at the reactions, the chemical reactions, right, we have on the next page, you have magnesium hydroxide is going to react with any type of acid. So the acid typically in our stomach is hydrochloric acid, so it's going to react with hydrochloric acid, and in particular 2 of those, and give us magnesium chloride plus 2 water molecules out in the end. Does anybody know what type of reaction this is? You learned your name reactions, I believe, right?
Is it neutralization?
Is which one?
Neutralization reaction.
The neutralization reaction, and neutralization is fits into what type? Apparently my earbud's not working. It's a double displacement reaction, or double replacement, depending on which book you look in. So yes, it is this neutralization is a double displacement, right, where we have the 2 hydroxides, right? These exist in the form of Mg2+, and you have actually 2 hydroxide molecules there, plus you have 2 protons, H+, plus 2 chlorides, right? So if we broke down and we think about each of these reactants in solution, when they're in solution, they exist as ions, and you can see how we're going to react between the 2 protons. The protons are going to form a double displacement or double replacement between the protons and the magnesium ion, and they react to give us our water, and then we end up with, let me correct the magnesium chloride, you end up with magnesium chloride dissolved in solution, aqueous solution of magnesium chloride for the other half. The same thing goes for the calcium carbonate, right? For calcium carbonate, this is going to react with hydrochloric acid in a similar fashion to give us our, first off, calcium chloride, plus we're going to form, in the first step, H2CO3. So that's, if you were to simply draw out the reaction, you can see that the first step you form H2CO3. Well, H2CO3, if you look in your in the manual, what it actually shows is calcium chloride plus carbon dioxide plus water. Is anybody familiar with what this particular acid is known as? H2CO3.
Is it carbonic acid?
It is carbonic acid, and has anybody ever drank carbonic acid before? Anyone? No one? Anybody ever have a carbonated beverage? Soda? Anything else? There you go. So when you take soda and they place a high pressure of carbon dioxide over water, and that forms actually an equilibrium of carbonic acid in water. So what you're actually getting here is, the reaction of the acidic taste that you get from Coca-Cola, for example, is because of the fact that they dissolve carbon dioxide in water, and that forms carbonic acid. And then when you open the bottle, the equilibrium goes in the reverse direction. You reform some water, and you get your fizzy bubbles out in the form of carbon dioxide. So you can see when you take a calcium carbonate tablet or a Tums, you're actually going to react with the acid in your stomach, and you're going to be giving off carbon dioxide and water because of the fact that you form carbon dioxide that eventually releases form carbonic acid, which eventually releases the carbon dioxide and water. So, and then the last one is the sodium bicarbonate or baking soda. If anybody's ever done any baking before, you can understand what's going on here. We add a little baking soda to any type of baked goods, and you end up adding the baking soda for the purpose of having a rise occur, right? And the rise occurs because of the fact that baking soda reacts with not necessarily hydrochloric acid, but other acid sources that are present in your baking solution, and they give off carbon dioxide gas bubbles, which make the substance rise and gives you your nice fluffy pancakes or bread or anything along those lines. All right, so you can see now what the neutralization reactions are, where we've basically, you can use various types of bases to react with the acids in your stomach to form neutral molecules. And so we have a neutralization occurring. All right, so you can see they give you examples in the textbook. They talk about different types of acids, right? Any types of acids they have. We have, they're not talking about it in particular, but in particular, they talk about the acid that's in your stomach. So we're talking in this case, your different gastric juices. Right, the gastric juices are typically going to be around a 0.10 molar solution of hydrochloric acid. Is going to be one of the primary acids that are in your solution, in your stomach. This ends up being a pH of approximately equal to 1. So you'll see in the video that I posted that we're starting with a pH pretty close to 1 for our 0.10 molar hydrochloric acid solution. You'll see that I go through and essentially follow the procedure. I'm going to be adding magnesium hydroxide pure. I'm going to be adding magnesium hydroxide, calcium carbonate, and sodium bicarbonate. And pay attention to the amounts here. I'm only adding 0.250 grams, or approximately 0.250 grams to the solution. And we're going to look at the effect, as this will allow us to compare the acid neutralization capability of each of these different types of bases. And then in the experimental portion, we'll be using the TUM.
I think you muted your mic, Dr. Barbosa.
Thank you. How long ago did I mute my mic?
About a minute.
Thanks for chiming in. Well, I am trying to keep track. My phone falls asleep, so I don't see the comments all along the way. Sorry about that, everyone. So I don't know where I left off, but I must have touched the. Let me try to move
somewhere,
this over.
Somewhere near Publix Tums.
Oh, public stems. Okay. All right. So what I was saying is, right, we're going to test the different concentrations of magnesium hydroxide, calcium carbonate, and sodium bicarbonate, recognizing that we're only using 0.250 grams of each of these. And then we're going to be using the Publix, the Tums brand, the Tums brand, the Publix brand of Tums, 300 milligram, 3 tablets of 500 milligrams, which is right 0.500 grams of each. So right, we have a total of 1.500 grams of total there. And we're also going to be using the ultra strength. And the ultra strength, we're going to do 3 tablets and 1,000 milligrams a piece, or 1 gram, right? So we have 3 total grams of calcium carbonate that we're adding there. And the last one what they're going to be using is the Maalox equivalent, which gives us, we're going to be doing 20 milliliters of the Maalox equivalent. Typical dose, though, is measured as 5 milliliters, contains 200 milligrams of aluminum hydroxide and 200 milligrams of magnesium hydroxide. And you can see we're obviously going to need to multiply each, because we're using 20 milliliters, so we have to multiply each of these by 4, right? Multiply each of these by 4 in order to get a total of 800 milligrams of each. So pretty much larger doses than we're using in the pure substances. And then what you're going to be doing for the lab is just pretty straightforward. You're going to, I see that most of you submitted the pre-labs already, which is great. Thanks for doing that. You're just going to be filling out the quantities and the pHs in the lab experimental procedure. Now, obviously, in order to do that, you have to watch the lab. And then you're going to answer the questions on the back. So it should be pretty straightforward from that perspective. And I'll be available to answer any of the questions that you have along the way. You can email me and the like. The video, I've shortened it down, so it's only, I think, just under half an hour. So it shouldn't take you too much longer. So within the next another half an hour watching video and maybe 15 minutes, 20 minutes of answering questions, you should be able to get the lab done in an hour and 15 minutes, an hour and a half. So probably a little shorter than you would have if you were sitting here in class. Any questions?
Will it be due at 4:15?
Yeah, you have to do it now. Yes, correct. That's the point. You have to get it done now. I was asked by the vice president and by the president during our meeting. They told us that we were to run these like normal class sessions and have normal due times, just like we would have if we were running the class. So we're doing exactly that. So you're basically expected to work through everything right now and continue and submit it all just like we would have if you were in lab.
One more question. So like these calculations that you wrote, like for example, for like the part 1 of our lab report sheet, like mass of magnesium hydroxide, etc., is that going to be in the YouTube video?
Correct.
Okay.
I record myself weighing everything out, and I record everything, taking the pHs.
Okay.
Yeah, so you can watch and monitor all the different reactions. You can pause along the way, obviously, and fill things in. Other questions? It's probably a lot easier than most of your other classes. But we have to make a certain number of, complete a certain number of labs in order to meet SACS accreditation for your degrees. So I have to move forward. At least, because this is only going to be, this was only the 5th lab, so we weren't quite at the we were just at the halfway point. So that's kind of where we're sitting from that. That's why I needed to do at least one more. Any more questions? Most of this presentation's obviously been recorded. It will show up after everyone logs up. It should pop up in the list. So if you do need to refer back to the video, it will be there and you'll be able to access it yourself and watch the video. I'm going to try to download it, but it'll take a while for me to download and then upload to YouTube and post it. So don't expect to see that right away. Other questions? Let me just go check. Stop sharing. Did we get any new additions? Anybody show up late? Let's see. Madeline's here. Hey. Let's see. Is Katie here? Katie's here. All right. A little late. Sophia did not show up. Sophia, you here? If you are, say hello. Emily's here. James, are you here? All right. Any other questions? Going once, going twice. Hopefully everybody stays safe. Make sure, take care of yourself. If you hear anybody coughing, run for the hills. Many of you are athletes, you can run fast. Just kidding. So stay safe, stay healthy, and hopefully this works out. I will talk to you later. If you don't have any other questions, I'll let you guys start exiting. Say goodbye.